Hello friends, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about nucleophilic aromatic substitutions. You know friends, substitution reactions in which the nucleophile displaces a good living group such as halide on an aromatic ring. So you can see here benzene contains living groups react with nucleophile forming nucleophile aromatic compounds and living groups Lg is removed. So here Lg means living groups and Nu means nucleophile. Now aryl halides are inert to both Sn1 and Sn2 nucleophilic substitutions. What is the mechanisms? Mechanism must be different. You can see dissociation reactions does not occur because the aryl cation is unstable. Therefore, no Sn1 reactions. You can see sp2 orbital unstable cannot. And backside displacement is sterically blocked. Therefore, no Sn2 reactions. Now, SNAR mechanism or addition elimination. SNAR mechanism or addition elimination. Remember it. SN aromatic mechanism or addition elimination. Elimination, addition or Benzyne mechanism. Sn1, SRN1 mechanisms. So mechanism of nucleophilic aromatic substitution. Most common is addition elimination means SNAR mechanism, and Benzyne mechanism means elimination addition reverse. Last two are not very common. So SNAR mechanism or addition elimination mechanism. SNAR mechanism or addition elimination mechanism. You can see the living groups. You can see the nucleophile. RDS means rate determining step slow. You can see mesenchymal complex, resonance stabilized, fast, and formation of the product. So addition and elimination. You can see the next addition and elimination. So resonance stabilize structures. So condition, there must be an electron withdrawing groups at the benzene ring which can stabilizes the negative charge. Ring must be activated by electron withdrawing groups like N2, cyanide, CF3, COOR, COOH, etc. You can see examples. Excess ethanol, 60 degrees Celsius, formation of these products. Then you see the chlorine, NSCH3. And you can see the chlorobenzenes not go under CH2, CH3, NH2 because there is no electron withdrawing groups. But at para position and ortho in para positions, reactions occurs because both NO2 group presents. Without NO2 group present, reaction is not happening. You can see Chichi-Bevin reactions. Pyridine is so much activated towards the addition elimination that it does not require any electron withdrawing groups. But this is the beauty of the Chichi-Bevin reaction. Pyridine is so much activated toward the addition elimination that it does not require any electron withdrawing groups. Now you see the reactions. If you have any two groups, this reaction is resonance stabilized and formations of products. Now energy level, you can see the additions, slow step and fast step, then eliminations. So this is the energy profile for SNAR. Proof of this argument comes from the fact that order of reactivity for halogen is F greater than Cl greater than Br greater than I, or not the reverse of this, that is I greater than Br greater than Cr greater than F, based on their living group's ability. A stronger bond dipoles associated with the more electronegative atom favor the addition step, thus lowering the energy of activations of the nucleophile addition step. You can see which is rate determining steps. Now friends, Benzyne mechanisms. addition, elimination. You can see bromobenzene undergo reactions and forming aniline. Actually, this reaction is addition-elimination reaction. No activation of benzyne ring by any electron withdrawing groups. A strong base is required. The rate of various aryl halides toward this reaction follow the order, so addition-elimination pathway is not possible. Now, benzyne mechanism, addition-elimination, you can see the formation of benzyne and then formation of aniline. You can see the triple bond between sp2 carbon pp overlap, sp2 sp2 overlap, weak bond, benzyne unstable and reactive intermediate. Slowest step may either be proton abstraction or leaving groups. Leaving of leaving groups. The incoming groups doesn't always take the position vacated by the leaving groups. So you can see the formations of two products if you label it with the carbon 14s. If you block the ortho positions, you will find no reactions. Regioselectivity in benzyne mechanism with respect to its formations. When there are ortho and para groups with respect to the leaving groups, you can see the ortho groups must form benzyne and para positions, so must form this. So when there are meta groups with respect to the leaving groups, meta groups, you can see the formation of benzyne positions and the formation of benzyne position. Z is equal to minus I effect and Z is plus I effect. Just remember, that is very important. Ortho positions, you have the benzyne, and para position, you have the benzynes, but at different effect. Regioselectivity in benzyne mechanism with respect to product formation. You can see symmetric benzynes, only products. Unsymmetric benzynes, you have the two products, one plus I effect and minus I effect. Minus I effect and plus I effect. Now, Sn1 mechanisms. You can see benzene disonium chloride nucleophile formations of the products. They depends only on the electrophile and independent on the concentration of nucleophile. Now you can see the positions of hydrogen. You have to change hydrogen with the deuterium. Ki 1.22, Ki is kinetic isotope effect. Ki kinetic isotope effect. So stabilizations of phenyl cation by hyperconjugation. Stabilization of phenyl cation by hyperconjugation. Now Sn1 mechanism, you can see the step 1, removing N2 plus formation of benzyl cation, and then second step formations. Not so common, only occurs when there is a super leaving groups or benzyne like N2 and triplets. SRN1 mechanism, you can see 3-methyl group and adenine react with N2 forming two products with different ratio. No activation of aromatic ring, so no addition-elimination mechanism. If benzyne mechanism, then the above products should be formed in equal proportions. Sn1 not possible because only possible with the super leaving groups like N2. So difference mechanism called as SRN1 mechanism. So be careful with the SRN1 mechanisms. You have 3-methyl group at different positions, iodine, and this reactions is followed. You can see the formation of anion radicals and then formation of products. Not so common mechanism, only occurs with aryl halides. Thank you. If you like this video, then subscribe my channel, and thanks for watching.